Hello everyone. This video will be going over simplifying rational expressions. Okay. Now, a rational expression is simply just a combination of numbers, variables, or polynomials that can be written as a quotient. And quotient is just another way to say fraction. Alright, so let's give a few examples of what a rational expression could look like. Of course, it could look like many different variations, but these are just a few examples. Okay, so you have 3x squared over 8 is a rational expression. You have 5 over 2y. That's a rational expression. You have 2 over 7. That's a rational expression. If you have x squared plus 2x plus 1 over 3x plus 8. That's a rational expression. Okay, so any combination of numbers, variables, or polynomials. Okay, so the one thing that you want to remember from the old fractions that you learned before is that when dealing with quotients, or fractions in this case, your denominator cannot equal 0. Okay? So to find undefined values of a quotient, we do that by finding the values that make the denominator equal 0. Okay? Alright, so if you're still writing, please feel free to press pause, but we're going to go ahead and go to our first example. So, move this down a little bit. There we go. Okay, so let's say, for example, we want to find any values that exist where the following rational expressions are undefined. Okay, so for our first problem, we'll call that problem A. That's x over x minus 3. Okay, and we'll have problem B. We'll make that x plus 2 over x squared minus 3x plus 2. And for problem C, we'll make that x to the third power minus 6x squared minus 10x plus 8, all over 7. Okay, so we want to find the undefined values for all of those. All right, so let's start with problem A. Okay, so if we have x over x minus 3, the one thing we know for sure is that that denominator cannot equal 0. So that means x minus 3 cannot equal 0. So if we go ahead and add 3 to both sides, that lets us know that x can equal 3. Okay, now you can plug x as any other value. You can make it 1, you can make it 2.8, you can make it a billion, you can make it any number in existence except 3. Because the minute you plug in 3, you get an undefined quotient. Alright, So let's say for problem B, move this up a little bit. We have x plus 2 over x squared minus 3x plus 8. Okay, so just like before, the one thing we do know is that our denominator can equal 0. That means x squared minus 3x plus 8 cannot equal 0. Okay, so if we go ahead and factor this using the steps for factoring that we learned in earlier videos, we see that's x minus 1 times x minus 2, which cannot equal 0. Oh, why did I put 8? I meant to put 2. Sorry about that. Little mishap on my part. I think I was looking at this one and kind of threw myself off a little bit. Okay, so we have x minus 1 times x minus 2 cannot equal 0. So that means we can't let this become 0, because if this becomes 0, 0 times anything will be 0, which we can't allow. We can't let this one become 0. Okay, so that means x minus 1 can equal 0, and x minus 2 can equal 0. Okay, so if we add 1 to both sides, we see that x can equal 1. And if we add 2 to both sides, x can equal 2. Okay, so that means for this expression, you can plug in any value in existence and you'll be okay, except 1 and 2. As soon as you plug in either 1 or 2, you will make that undefined and it just won't exist. Okay, move this up and we're going to go to problem C. We have x to the third power minus 6x squared minus 10x plus 8 all over 7. Okay, you may not realize it, but this is actually the easiest out of all three. Okay, because we know that can never equal 0, so we know that 7 cannot equal 0. Okay, so this tells us that no matter what we replace x with, there's no magical way to make 7 equal 0. It's just not going to happen. You can't make it equal 0. So that means there are no undefined values. You can plug anything up here, and it's not going to make that denominator 0. Okay, so you have no undefined values. All right. Okay, so what we're going to do now, we're going to go up to the top here and do a quick, I guess you could say, a quick refresher on interval notation. So since we know for A, x cannot equal 3, that means that x can equal anything from negative infinity all the way to 3. Then it picks up on the other side of 3 and all the way to positive infinity with the parentheses. Excuse my rather messy looking parentheses there. I mean, infinity. Okay, so we go to infinity and we'll close it on up. Okay, now this is your interval notation. Okay, now for this one, we can see that x can equal 1 and x can equal 2. So we're going to put our interval notation here. And we're going to go all the way from negative infinity to 1. Okay, so anything to the left of negative of 1 will be okay. But then it'll stop at 1. Then anything between 1 and 2 Okay, so you have anything between 1 and 2. And then it picks up on the other side of 2, and anything to the right of 2 is okay. Okay, so that would be your interval notation. Oh, let me clean up that parenthesis. I mean, not parenthesis. I keep saying parenthesis. By infinity. There we go. Okay, so that's the interval notation for that one. And for this one, since there are no undefined values, your interval notation would just be from negative infinity to infinity. Okay, so hopefully this makes sense. So we're going to go into simplifying our actual rational expressions. All right, move that on down there. There we go. Okay, so we're going to go our steps to simplify rational expressions. Okay, so it's just 2 steps, so it's not like it's a big lengthy process. Okay, so the first thing you want to do is completely factor your numerator and denominator. Numerator and denominator. Okay, so once you completely factor all of them, you're going to then cancel out any common factors. Any common factors. And simplify. All right. Now to do that, you just have to remember that anything divided by itself is equal to 1. So 2 divided by 2 is equal to 1. Y divided by y is equal to 1. X squared plus 9 over x squared plus 9 is equal to 1. Literally anything divided by itself is always going to be equal to 1. No matter how complicated or how simple, if it's divided by itself, it's going to equal 1. All right, so right up under here, we're going to start our example. Okay, so what if we wanted to simplify 5x minus 5 over x to the third minus x squared? Oh, let me clean up that 3 a little bit. Okay, x to the third power minus x squared. Okay, so if we have 5x minus 5 over x to the third power minus x squared, we can actually factor a 5 out of both of those terms up here. So our numerator becomes 5 times x minus 1. Over here, we can factor out an x squared. So we can factor out an x squared. That becomes x squared times x minus 1. Okay. Once again, anything divided by itself is 1. So as long as it's factored, we have just multiplication up here and just multiplication up here. So these two cancel each other out. So you're left with 5 over x squared. So that's how you simplify your rational expression. All right. So let's go on to our next example. Okay, so what if we wanted to simplify x squared plus 8x plus 7 over x squared minus 4x minus 5. All right, so I want you to press pause and try to do this one yourself. Okay, remember, first thing you want to do is you want to factor your numerator, factor your denominator, and then cancel out any common binomials. Any common factors. Okay, so I'm assuming you've gone ahead and factored out anything in common. And you're all done. Okay, so let's see if we have our x squared plus 8x plus 7 over x squared minus 4x minus 5. Okay. Now if we factor our numerator, we know that that becomes x plus 7 times x plus 1. Because using our steps, we can see that if we find two numbers that multiply to equal 7 and add to equal 8, it's just 7 times 1 and 7 plus 1. Okay, and here if we find two numbers that multiply to equal negative 5 and add to equal negative 4, that's just negative 5 and 1. So you have x minus 5 and x plus 1. Okay, so we can see here, anything divided by itself is just 1. That becomes x plus 7 over x minus 5. Okay, so that's your simplified answer. All right, so what if we had another example here? Let's say, for example, if we wanted to simplify x squared plus 9x plus 14 over x squared plus 12x plus 35. Okay, and again, I want you to give that one a try. So go ahead and press pause and try that one yourself. Alright, so assuming you're all done with this one, we have x squared plus 9x plus 14 over x squared plus 12x plus 35. Find two numbers that multiply to give you 14 and add to give you 9. We know that's 7 and 2. 7 times 2 is 14. 7 plus 2 is 9. So we have x plus 7 times x plus 2. Okay. For our denominator, we find two numbers that multiply to give you 35 and add to give you 12. We know 7 times 5 is 35, and 7 plus 5 is 12. So we have x plus 7 times x plus 5. Okay, so anything divided by itself is just 1, so those two cancel out. So we're left with x plus 2 over x plus 5. Alright, so let's try one more of these. What if we wanted to simplify x squared minus 9 over x plus 3 squared? Alright, and I want you to give that one a shot. Okay, so go ahead and press pause and give that one a try. Oh, quick hint. This is a difference of squares. Alright, so I'm assuming you're all done with this one. Let's move that up a little bit. So if we have x squared minus 9 over x plus 3 squared, we know this is a difference of squares. So it's just x squared minus 3 squared. Uh-oh. Leave that there. So we have x plus 3, x minus 3. Okay, we can see here x plus 3 squared is just x plus 3 times x plus 3. Okay, anything divided by itself is 1. That's just going to be x minus 3 over x plus 3. Alright, so hopefully this has made sense. So this has made sense. We're going to move on to one final thing I wanted to point out, because more times than not, you're going to run across this little problem. Okay, so if you're still writing, feel free to press pause, but we're going to move on to our last thing we're going to cover. There we go. Okay, so quick note. If you have two terms separated by a minus sign, you can actually switch them up by multiplying them by -1. Okay, so you have -1, instead of y minus x, you can make that x minus y. Okay, because remember, if you get the -1 and you distribute it to both of those, -1 times x is -x, -1 times -y is +y, so you get -x times plus +y, and you can just flip those around to be y minus x. Okay, so for example, if you have 3 minus x, you can make that equal -1 times x minus 3. Okay, so that's a very, 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 very handy trick, because it will come up over and over and over and over and over again. Okay, so definitely make sure you remember this. Okay, so let's say, for example, we want to simplify. Say for problem A, we have x plus y over y plus x. Say for problem B, you have x minus y over y minus x. And let's say for problem C, we have x minus 4 over 4 minus x. Alright, so I'm going to leave this one for you to do, but we're going to go ahead and do problems A and B. Okay, so for problem A, we have x plus y over y plus x. We know that just equals x plus y. Addition is commutative, which means 2 plus 3 is the same as 3 plus 2. So y plus x is the same as x plus y. Okay, so if you wanted to, you can multiply each of these by 1. You don't have to, but you could, because we know anything divided by itself is just 1. So you have 1 over 1, which is 1. Okay, now that's what you can do with addition. If we look at problem B, we can't do that because x minus y over y minus x, you can't just flip it across a minus sign, because we know that 3 minus 2 is not the same as 2 minus 3. You'll get two completely different answers. One's positive 1, one's negative 1. Okay, so you can't just flip it across a minus sign like you did with this one. Okay, that's where this little trick comes in up here. Okay, so we have x minus y, and again, you can go ahead and multiply it by 1 if you like, over y minus x. Remember, we can make that negative 1 times x minus y. Remember, make it out, multiply by negative 1 and just flip them around. Okay, and we see here, anything divided by itself is just 1. So you have 1 times 1 is 1, and negative 1 times 1 is negative 1. So here your answer will be negative 1. Okay, so if you ran across this problem and you put just 1, it would be incorrect. All right, so I want you to go ahead and do problem C, which is x minus 4 over 4 minus x. All right, so assuming you've pressed pause and you've worked this one out, we know, and this way we're going to kind of flip it a little bit and do it a little bit different, but you can do the numerator or denominator. You don't have to just flip the denominator. But if you make this negative 1 instead of x minus 4, you can make that 4 minus x, and make that just 1 times 4 minus x if you want to. Anything divided by itself is just 1, so you still have negative 1 over 1, which is negative 1. Okay, so you don't have to flip just the denominator. You can flip the numerator if you like, and you'll come up with the exact same answer. All right, so that's it for this lesson, and I will see you on the next video.